So here's the setting. N independent coin tosses. And each coin toss has a probability P of resulting in heads. So this is our probabilistic experiment. Suppose we do 6 tosses. What's the probability that we get this particular sequence of outcomes? Because of independence, we can multiply probabilities. So it's going to be the probability that the first toss results in heads, times the probability that the second toss results in tails, times the probability that the third one results in tails, times probability of heads, times probability of heads, times probability of heads, which is just p to the fourth times 1 minus p squared. So that's the probability of this particular sequence. How about a different sequence? If I had four tails and 2 heads, but in a different order, let's say if we considered this particular outcome, would the answer be different? We would still have p times p times p times p times 1 minus p times 1 minus p. We would get again the same answer. So what you observe from just this example is that more generally, the probability of obtaining a particular sequence of heads and tails is p to a power equal to the number of heads. So here we had 4 heads, so there's p to the fourth showing up, and then 1 minus p to the power number of tails. So every k head sequence, every outcome in which we have exactly k heads has the same probability, which is going to be p to the k, 1 minus p to the n minus k. This is the probability of any particular sequence that has exactly k heads. So that's the probability of a particular sequence with k heads. So now let's ask the question, what is the probability that my experiment results in exactly k heads, but in some arbitrary order? So the heads could show up anywhere. So there's a number of different ways that this can happen. What's the overall probability that this event takes place? So the probability of an event taking place is the sum of the probabilities of all the individual ways that the event can occur. So it's the sum of the probabilities of all the outcomes that make the event happen. The different ways that we can obtain k heads are the different sequences that contain exactly k heads. We just figured out that any sequence with exactly k heads has this probability. So to do this summation, we just need to take the common probability of each individual k head sequence times how many terms we have in this sum. I'm interested in particular sequences that have exactly k heads. So what I need to do is to choose k slots and assign heads to them. Okay. So to specify a sequence that has exactly k heads is the same thing as drawing this picture and telling you which are the k slots that happen to have heads. So I need to choose out of those n slots, k of them, and assign them heads. In how many ways can I choose these k slots? Well, it's the question of starting with a set of n slots and choosing k slots out of the n available. So number of k head sequences is the same as the number of k element subsets of the set of slots that we started with, which are the n slots 1 up to n. We know what that number is. we counted before the number of k element subsets, starting with a set with n elements, and we gave a symbol to that number, which is that thing, n choose k. So this is the final answer that we obtained.